Hi guys, it's Catherine and I'm going to show you guys how to do a thermodynamics question. So the question is number 138 and it reads, sulfur can be separated from lead in mineral galena, PBS, lead, by roasting the ore in the presence of oxygen as shown in the following reaction. So it's 2 PBS plus 3O2 yields 2 PbO plus 2 SO2 gas. Determine delta G for the above reaction at 850 degrees Celsius. So as you can see, I have the values right here, so for reference you should probably write them down because we're going to need them. And the formula that we're going to use is delta G is equal to delta H minus T delta S. So it's just change in delta G is equal to change in delta H minus temperature times change in delta S. So now I'm going to erase this right here so that I could have more space. And now we can calculate for delta H. So using the values that we had on that little chart, we can solve for delta H by doing the summation of the number of moles times delta H of products minus the summation of number of moles H of reactants. So as you can see here, the 2 PbO and the 2 SO2 would be your products, and the 2 PbS and the 3O2 would be your reactants. So now if we plug that in to the products and reactants of this equation, we'll get the sum of 2 times negative 217.86 plus 2 times negative 296.4. So that'll be the products minus 2 times negative 94.3 plus 3 times 0. And that will be your reactants. So from here, if you calculate what you get, you'll get negative 1028.52 for the products minus negative 188.6 for the reactants. And your delta H for this equation will be negative 839.92 kilojoules per mole. Now since this is in kilojoules per mole, I'm going to convert it to joules per mole because standard entropy is joules per mole Kelvin. And this would end up being negative 839,920 joules per mole. So now you guys can write that down, and then I'll solve for delta S. So now to solve for delta S, it's basically the same equation that we're going to use from delta H, except of course it's going to be standard entropy. So it's going to be delta S reaction is equal to the sum of number of moles standard entropy of products minus the summation of the number of moles standard entropy of reactants. So if I plug in everything from here, I'll get the sum of 2 times 91.2 plus 2 times, oh excuse me, that's wrong. It's 2 times 69.45, sorry, I got the numbers confused, plus 2 times 248.5, and that will be your products, plus the sum of your reactants, which is going to be 2 times 91.2 plus 3 times 205.0, and that's going to be your reactants. So now if you calculate that, you'll get 635.9 to 5 minus 797.4, and then you'll get, for your standard entropy of your reaction, you'll get negative 161.5 joules per mole Kelvin. So now if you guys want to write that down, that'll be for your standard acid reaction, so I can erase it and we could find delta G. Okay? Okay, so now to find delta G, so as you can see here, it's temperature, and we've been using joules per mole Kelvin and kilojoules per mole. So now we have to convert the 850 degrees Celsius and add it to 273 so we can get kelvins, and be 1123 kelvins for the temperature. So if you plug all of what you got, the delta H and the delta S, to this equation right here, you'll end up getting delta G is equal to negative 839,920 minus the temperature, which is 1123 Kelvin, and this one right here is joules per mole, times negative 161.5 joules per Kelvin mole. So now you just cross out, so moles cancel mole, joules cancels joules, and you're left with the delta G. And so you end up getting delta G is equal to 658,555.5 joules per mole, and it's asking for kilojoules per mole, so that would just be negative 660 kilojoules per mole, giving you, yes, that would give you negative 660 kilojoules per mole. So that's your answer. I hope it was a big help. Sorry I had to keep erasing and writing more things, but I hope it wasn't overwhelming. Thank you so much for watching, guys.